I wanted to know how well AI can make physics simulations, so today I'm going to put it to the test by seeing how well it can simulate fast hydrogen collisions. The question is whether AI walks the walk or just talks the talk. The reason I'm making this is because I'm gradually realizing that for a lot of things nowadays, AI is better than people. For front-end web development, for a non-professional front-end web developer, the AI can probably make that website better than you can. But for physics, it might be different because physics tends to have a lot of spatial reasoning, a lot of physics intuition, and the question is whether or not AI can match a person at that. Now, the challenge I'm going to give it is to collide two fast hydrogen atoms. So you have a hydrogen atom from the left and one from the right. They come into the middle, they bounce off each other, and their electronic structure gets changed by the collision. Now, I'm going to use Claude Opus 4.5, ChatGPT, and Grok. And for Claude, for the first run, I'm going to try and guide it through the problem. I'm going to work with it, I'm going to look at the simulations, I'm going to tell it what's wrong, I'm going to get it to iterate. But then I'm going to just go and see how well each of these can just solve the problem by themselves. So here's the first frame. I told it how to render it. I told it I want a checkerboard ground, and I want the sun, and I want it to be ray traced, and that I want the refractive index to match the electron density. So this looks promising. But then, unfortunately, after that, I hit problem after problem. It chose the wrong integrator, it chose the wrong basis set, it made bad assumptions, it set up the Hamiltonian wrong, a whole load of things which just needed to be iterated. Now, a person would also do this, make these mistakes, but then the person would kind of go over and iterate in the same way as I'm having to do with Claude. So yeah, a few kind of misfires, a few steps in the wrong direction, but ultimately it made this animation. Now, this animation to me looks about right. There's nothing about it that I think, yeah, that's obviously messed up. But I looked at the code, and it was all basically one big lie. One of the things that makes quantum mechanics difficult to solve is that when you have one electron, it's a three-dimensional problem. But if you have two electrons, it becomes a six-dimensional problem. And that just becomes exponentially harder than solving a one-electron problem. And the way the AI got around this was simply to say, no, there's only one electron. The electron might be on one atom or the other atom. And so the code was not doing the right thing. It was not using the right basis sets or anything. It was just one big lie. But because I'm guiding Claude through this example, I told it to fix it, I worked with it, I set up basis set, I worked with it to make tests to check that the energies were right. And and then I got this result. So I think this basically works. I haven't checked every single line in detail, but this is doing what I expected to do. The symmetries look right. The whole thing looks quite truthy. So yeah, so success. But this is a success with a lot of heavy work. This took about a weekend, a bit more than a weekend of my time to try to get right, and it did work. Claude did save a lot of time getting the standard algorithms to work. This would have been a lot more than just 2 weekends to get to work normally. This would have been like several weeks' work probably. So yes, I mean, that's a success for Claude. Claude is doing what it says on the tin. So with this in mind, I'm going to try one-shotting this, where I just give it a slightly more detailed prompt that just says, I don't want a toy example, here's the problem, can you go away and just solve this? If you need to do tests, do tests. If you want to do a code review and check your work and then proceed, do that, but you're doing this by yourself. So for Claude, here's the result. It doesn't really work. It doesn't really do what you want it to do. So I went in and gave it a little bit of advice that the atoms are not really oscillating, they should oscillate after the collision, and it went away and worked out that problem and fixed it. But the whole point is to see how far it can get by itself, and so, yeah, not very far is the answer. Then I tried ChatGPT 5.2. This is not the premium version, this is the free version, so perhaps the premium version would work better. And it had several attempts. I did do the same thing where I explained that no, what it's done isn't really working. But this actually did worse than Claude, in my opinion. There's no real physics here. This is really just a toy. And not just a toy in that it's got one electron. It's actually worse than that. It's not really doing any quantum mechanics here at all, basically. Then, yeah, and you see here it admits it in quite a lot. It's like, no, yeah, this isn't real physics. And then, so here's Grok 4.2. Again, this is not the premium version. It's just the bog standard Grok. But now Grok was able to talk the talk. Grok went through the papers, it talked over the history of the problem, it talked about different approaches, it read over the archive, as many papers as it could. It really gave the impression that it was about to do something PhD level. But it's complete rubbish. The answer just does not work. There's not even a toy working example. It's not just that, okay, it made a syntax error, so it doesn't compile. So, I mean, from this, basically, I would conclude that at the start of 2026, these AI models cannot really do proper physics. They can save you an absolute ton of time by implementing things that are fiddly, like Chebyshev integrators on non-orthogonal bases. It's very good at that. It's very good at the Wigand-D matrices. All the complicated things that are standard, it does well. What it really can't do is that physics intuition. The spatial reasoning is just not really working well enough for it to solve this problem by itself. Now, I've seen that before. I tried to get it to design a robot chassis, and it doesn't really work because it just doesn't seem to have that spatial reasoning. Anything where you need to reason about where things go or which angles things are, it just doesn't really have. But as I said, these are not the most expensive models. Maybe Claude is, but ChatGPT and Grok no. And these things are improving all the time, so you might have more luck in 6 months. But for now, it can do the maths, it can do the algorithms, but it can't really do the physics intuition. So if you enjoyed this, don't forget to subscribe and have a good day.